Moldflow 2017 R2 release introduces great new features and enhancements that increase capabilities, enhance solution accuracy, and reduce time to solution. Here in this video, let's have a look at 3 key areas for direct geometry editing, parametric optimization studies, and 3D resin transfer molding. How often do you notice design modifications are necessary when you begin working on a project? Maybe some areas are too thick or too thin. Or perhaps you want to see the effect of slightly moving a feature like a rib or boss. You could consult with the designer and ask them to make the design change, or you could attempt to make the change in a tool like SimStudio. But in the cases where features are connected to a fillet, this may become a challenging effort. Moldflow 2017 R2 release provides new tools that enables you to make some small design changes directly within Synergy. The intent of these new tools is to make thickness changes or move specified features of the design. In the model shown, the base wall thickness was modified to maintain a more uniform wall thickness of the overall design. The user may also use the preview button to check if the modification is valid and commit to the change. The backface thickness can be altered using the Preserve Shape of Fillet Chamfer Faces option. Checking this option will translate the fillet with the movement of the face. Features can be translated or moved using the Vector tool. By running both the original and revised model in Moldflow, the analyst can verify the design changes. If they are satisfied with the final revised model, the user has the ability to export the revised design as a CAD model. These new tools enable an analyst to make minor model changes directly within Synergy to see its effects quickly and easily. The Moldflow Insight 2017 R2 release adds the capability to quickly explore a number of design variations and observe how they impact results like filling and warpage. This could be done by driving the design changes through a parametric study. In the model, the user is able to select faces they want to consider for modifications. But instead of applying the design changes, they will select the option to save CAD modification. Once the modifications are selected and saved, the user will go to the Parametric Study Builder. The design changes will be visible along with the other standard variables that can be adjusted. The Parametric Builder will attempt to create all possible permutations of the model and automatically mesh and run the analyses. The parametric study analyses can be submitted to the local machine or to the network. However, this is where the power of the cloud is priceless, as it will mesh and analyze all combinations simultaneously. At the end of the standard result plots, the analyst will see a Parametric Study Explorer, where they can compare the various analyses and explore which of the permutations are potentially the best candidates. The user is also able to select which of the runs they would like to import into the study as individual studies to do a final comparison with full results. By using a parametric study, an analyst can quickly explore various design changes and their overall effect on the final part. In the resin transfer molding and structural reaction injection molding analyses, resin is forced to flow through a cavity in which a reinforcing preform is present. The reinforcing preforms are typically carbon fiber or glass fiber mats that are placed in the mold in dry form, and a thermoset resin is injected. Once the thermoset is hardened out, the new product forms a lightweight, hard, and strong composite structure. The strength is provided by the carbon or glass fibers, while the resin, often an epoxy, forms the glue that keeps the structure together. The lightweight but extremely strong properties make this a very appealing process for automotive and aerospace applications, where these properties are highly desirable. In the last few years, material suppliers have developed fast curing grades, especially for automotive applications. In the Moldflow 2017 R2 release, the end customer can provide a preform 3D property to the area that the preform will be placed. The user can then specify the permeability properties for the preform and the orientation of this preform in the mold. The software will automatically have the fabric follow the contours of the part. The simulation can be used in combination with vacuum locations to promote permeation of the fabric. The analysis also predicts the filling pattern and identifies problems such as cycle time. A process variant that has increased in popularity is the high-pressure RTM, which injects the resin under high pressure, reducing the time to fill the mold. This new 3D resin transfer molding capability is part of the Moldflow Insight standard license.